Assalamualaikum. Tidak pakai dulu. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Semua sihat lah.
Selamat Raya, sir.
Selamat Raya. Sama-sama selamat Raya. Highway itu penuh kereta pasal apa hal? Kata tak boleh balik kampung. I think many people went back home. You know, Pahang, Terengganu, Kelantan. No wonder, you know, Terengganu, Pahang, cases after Raya that increased by, I think, more than double. It's almost now 100 something. You know, Kelantan tak payah cakap lah. Kelantan already high. So I think many people actually went back home. Tak ikut SOP, bro. Alright.
Yang PJJ kot, sir.
Ada? Okay. Tak tahu lah.
No. I mean, maybe they PJJ, soldier, police.
Tak tahu lah.
Raya yang tu, dia orang boleh balik yang dah kahwin yang tu.
Tapi Raya tak boleh balik lah. You know, they can
agak jam. Saya Selatan tak jam, sir. Highway Selatan.
Itulah dia. Highway lain tak jam. East Coast dia jam. I don't know. But that is that's like normal, you know. That's like normal. Macam Raya biasa. Jam macam tu. So I don't know. Maybe some people they went back kampung. I think from Selatan, from Utara, not bad. Okay, you Selatan pada mana? Pada Melaka ke? Ke pada Johor?
Johor, sir, Johor. I drove to UIA yesterday.
Johor eh. Dia tengah kecoh pasal laksa Johor, laksa Kedah ni apa?
Oh.
I think dua laksa sedap. Laksa Pahang pun sedap lah. Laksa Kelantan sedap, laksa Terengganu pun sedap. Semua laksa sedap. Yang lain-lain kan. Tapi saya rasa Johor yang paling saya suka ni Mi Bandung muah lagi sedap.
Mi Bandung, mi rebus semua sedap.
Mi Bandung memang sedap. Kalau tempat lain tak sedap. Yang muah punya memang sedap. Okay, now let's get back to our discussion. Okay, so today we're going to do the application of the chapter 12.1, 12.2, and then 12.4. If we have time, we are going to move on to the next chapter that is on the definite integral, I think chapter number 13. All right, so that is my plan. And yeah, also I didn't tell you, I forgot to inform. There is another part of the integration that we need to look at, that is initial condition. So first we will look at initial condition. So that is our plan. So we want to look at initial condition. Now, what is initial condition? Okay, this is the thing that I need to talk about first. Initial conditions, and then we're going to look at applications. Okay, applications on chapter 12.1, 12.2, and 12.4. Now, initial conditions means that you want to find the value of the constant C in the integration. And of course, given a point. So you are given a point or given some information, we can find the value of the constant C, or sometimes they use K. Okay? So that is what you call initial condition. Now let's look at the idea. Now let's go back to the thing that we were doing last time. Where was it? Okay, I give you an example that we were looking at. Suppose this one. Okay, you have this example. Let's say, okay, here the power is too much, you know, but this is just to get the example. So you have the integration of the function f of x is equal to 8x cubed minus 12x, everything to the power of 11 divided by 11 plus c. So now you need to find that c. So in order for you to find the c, this is what you call an initial condition is given. Okay, initial condition is given. Now, what is initial condition? Initial condition means you are given simply 1 point. So you are given the value of x, and then the corresponding value of the function, in this case, the integral, and then you can find the value of c. So let's say, all right, let's say you have the point given. If x equal to 4, then if x equal to 4, suppose the function is equal to some value. Or I think we start something simple. Let's say at x equal to 0, okay, f of 0 is equal to, say, 2000 or 200. So this is an initial condition. Essentially, you are given 2 points, all right? At x equal to 0, f of 0 is equal to 200. So you are given a point. So what we do here is we simply substitute. All right, we substitute the point into the function. So what you will get will be f of 0 will be equal to what? Will be equal to 8 multiplied by 0 to the power of 3 minus 12 times 0, everything to the power of 11 divided by 11 plus c, and that is equal to 200. Okay? So what is c? C is equal to, everything here is 0. So 0, 0, 0, 0. So therefore, c is equal to 200. And then we put back the value c equal to 200 into the function. So the function you will get after we determine the value of that c will be f of x equal to 8x to the power of 3 minus 12x, everything to the power of 11 over 11 plus 200. Okay, so that is to determine the value of the constant k. Okay, all right, any question? Okay, we look at another example, a simpler example. Suppose we have the following. You have the function f of x equal to 2x cubed minus 4. All right, suppose that is the function. Now integrate this function, integrate f of x, and then you want to find f of x, find the value of the constant c, at the point, okay, x equal to 0, and then f of x is equal to n. I'm repeating myself. F of 0. We don't use 0. Now we use another point. Suppose at x equal to 10, all right, f of 10 is equal to 74. So that is the point given. Okay, that is what you call initial condition. So you're given 1 point, then you can find the constant. So first you need to integrate the function. And of course, to integrate the function is to integrate f of x, dx, that is equal to the integral of 2x cubed minus 4 dx, and that will be equal to 2x to the power of 4 divided by 4 minus 4x plus c. Of course, you can cancel that out, we got half. So that is our integral with the c. Now, in order for you to find the c, you substitute, okay? Substitute the point f of 10 equal to 74 into f. Then what I get will be 74. equal to 1/2 10 to the power of 4 minus 2, 4 times 10 plus C. So here you will get C. Okay. So this is equal to 40. Not this one not divided by 40. Okay, the value is 40. Here is times 4. 4 berapa kali 4? 10,000. Is that 1, 2, 1, 2, 3, 4. Terus 10,000. 10,000 over 2, 5,000. So you have 5,000 minus 40. You bring back to the other side. Berapa dapat? So 5,000 minus 40 got 4,960. Yeah, 4,960. Bring to the other side. You have negative 4,960 plus 74. Yang itu susah sikit lah. Berapa dapat? Okay. So that will be the value of C. Negative 6, and then here 15, 8, 4, 4,886. 4,886. So C will be equal to negative 4,886. Betul ke? Cuba cek. Cuba cek kalkulator. Betul tak? Betul ya? Saya kira betul lah. So that is the value of C. Okay? So that is C. So now you got that C, we substitute into the function. So therefore, your function will be equal to x to the 4 over 2 minus 4x minus 4,886. Right. Okay. So that is initial condition to determine the value of C. Nothing difficult. Everything is straightforward. So now let's look at application. So for application, we will continue to look at the book. All right. So let's start with 12.1. 12.1, you look at example number 7. Example number 7 is the first application that is on revenue. Now, the applications in this chapter are mainly the concept, okay, will be based on the antiderivative. We know the derivative, okay, you know the f prime of x. You want to find what is the function that we differentiate, you got f prime. So what we're doing is essentially we want to find f prime of x dx. And of course, that is f of x. So that is our idea. That's the idea of application. So if you look at example number 7, you are given the derivative of revenue. Okay, you are given marginal revenue. So marginal revenue is the derivative of revenue. All right. What you want to find? I want to find revenue. So you integrate marginal revenue, you got revenue. So if you look at further in this part, there will be other marginals. Okay, not just marginal revenue, but the marginals that we are familiar with. What are the other marginals? Marginal cost. Okay, marginal profit. And other derivative, sometimes they can just call it the rate of change. So if you are given the rate of change, you can find the function, okay, by integrating the rate of change of that variable. Okay, all right. So that's the idea of application in this chapter. Now, if you go back to that example, you are given the marginal revenue, and that marginal revenue is equal to the function given there. And of course, let's look at the detail, okay, a little bit detail. We have the marginal revenue for a good, and that good is motherboard, and the revenue is in dollars. So we have what? You have the X is the quantity of motherboards, the product, okay, motherboard in units. And then the revenue, okay, in dollars. And then you have yeah, that's it. And then you want to find revenue. And then you want to find revenue given, okay, find the total, you want to find revenue from sale of 1,000. So if X equal to 1,000, then you want to know what is R. So in order for you to find the R given X 1,000, you have to find the value of the constant C. Okay, all right. So yeah, this example, there are two things that we need to do. First, you have to integrate, get the revenue. Secondly, you have to find the constant C for the integral. So let's do the integration. So the revenue Rx is equal to the integral of the marginal revenue dx. That is equal to what? If I integrate that function, now very straightforward, 300 minus 0.2x dx. So what do I get? I get 300 minus 0.2x squared over 2 plus c, okay, the constant. And here you have 0.1. So you got 300 minus 0.1 x squared plus c. Yeah.
Is it 300x?
Yeah. You're right. Okay, 300x. Cuti raya ni dah lupa dah nak integrate. Banyak sangat makan lemang. Okay. Okay, 300x minus 0.1 x squared plus c. Okay. Now, in order for you to find the revenue at x equal to 1,000, what do we need? You need the constant c. Or the book use k. Okay, I use c. It's okay. Doesn't matter. You can use k, you can use c, you can use h, as long as that denote the constant. So, how can you find c? To find c, you must have an initial condition. Okay, to find c, you need a point. Okay, now, for revenue, there is one point that is true for every revenue function. What is that point?
0.
So, 0. Okay, so you need a point. But for revenue, they don't have to give you the point because we know that when R is equal to 0, the revenue, no, I'm sorry, when X equal to 0, revenue is 0. So this is true only for revenue, not for cost, all right, for revenue only. So to find the C, you substitute into R. So what do I get? I get R of 0 equal to 300, 0 minus 0.1, 0 squared plus C equal to 0. So therefore, C is 0. So your revenue now equal to 300x minus 0.1x squared plus 0. Okay, plus 0 tak payah tulis. So that is our revenue. So in order for you to find the value of C, we need that point. Okay, for revenue, they don't have to give you the point. Why? Because you know that when X equal to 0, revenue is equal to 0. So that is our revenue. So now you can find whatever revenue that you want to find at any output level. So given R equal to, X equal to 1,000, you can find the revenue, or, if you want to add another point or another output level, say at X equal to 59, you can also find revenue. Right? Okay, so that is example number 7 for 12.1 revenue. So for 12.1, I would like you to do some questions, application. Do number 41, 42. So 41 up to 43. And then do number 48, and then you do number 49. All right. Okay. I give you these questions. I want to do another question. Okay. We want to do number 46. Now, number 46 is not actually economic application. It's more like physics, science. So the concept is the same. What are we given? We are given what? We are given the rate of change of height. And then you want to find what is the height. You want to find the height. You want to find the equation for the height. So how do you do that? So basically we're going to do the integration. All right. And then we know that when t is equal to 10 seconds, the height is 1,600 feet. So you want to find the height, the equation for the height. So you see here, for this equation, you are talking about height. So the t is in seconds, the time, okay, time in seconds. All right, h is the height. So you are given the rate of change of height. So the rate of change of height is equal to v. So therefore, if you want to find the height, you integrate v dt. Okay? In other words, if you remember physics, if you take physics, the v here is the velocity, h is the height. So basically, h is distance. Is that right? The rate of change of distance is velocity. The rate of change of velocity, what is it? It's acceleration. So it's the derivative. In other words, acceleration is the second derivative of distance. So here we use height because it's going up into the air. So it's height, essentially distance. Huh? Then what is the function? The function is 320 minus 32t dt. And that is equal to 320t minus 32t squared over 2 plus c. And here you got 16. So 320t minus 16t squared plus c. Now I want to find c. So here you are given not when x equal to 0, what is the value of the function? You are given what? We are given when t is equal to 10, all right, the height is equal to 1600. So we have to substitute this thing here into the equation h. So substitute. What do I get? I get 1600 equal to 320 multiplied by 10 minus 16, 10 squared plus c. Okay. Now you do the calculation. What do you get? Add, subtract, add. So 320 multiplied by 10, you get 3200. So here 3200 minus 100. So 1600. Berapa dapat? 1600 campur sini, campur situ.
0, sir.
0. So C is negative 3200. Betul tak? C. Sebab 1600 dengan 1600 cancel out. So you got 3200. So C is negative 3200. So now you put back into the equation, you will get the height function. Put that. So that is number 36. No, I'm sorry, 46. So ada apa ke?
Then 3200 minus 1600 equal to 1600. And then
Yes.
3200.
And then 1600 bring back to the left, jadi 0.
0. 3200. If I do this,
The
you
C
bring
is 0, sir.
you bring 1600 sini ni to that side. Betul lah. So C is equal to 0. Thank you. Betul tak? Sebab ni negatif. Yeah, that is my mistake. This is a negative 1600. You bring to the side becomes positive. Betul tak? So 3200 minus 3200, 0. My mistake was I didn't change the sign. So I did it this way. That's an error. 1600 minus 1600, so 0. So itu mistake. So you have to be careful, okay? Especially with the signs, the negative, positive, you bring to other side. See. So that is importance of what? That is importance of the writing of the step. Jangan main kira pakai kepala otak je. Macam saya dah buat silap. Alright. So bring back. You know, do the step. So like I said, it's always good to write the extra step rather than just come up with the answer. So like what I did here, silap. Okay. Okay. So that is a real example of committing error when you want to do some work express. So do the step. All right, thank you. Okay, so C equal to 0. So C equal to 0, you put back into the H, you will get the equation. Okay, all right, good. Anything else? So I'll give you some questions on 12.1. That will be sufficient. Now we go to 12.2. Now 12.2, the applications are similar. You are looking at revenue, you are looking at cost, but the functions are application of power rule. So they don't have any example. What we do, we are going to look at the question, okay? Question in 12.2, we will do one of them. So 12.2, I would like you to do some questions and then we do one question, you know. So for homework, you do number 45, 46, and then 48, and then 50. 46, 45, 46, 48, 50. Okay. Oh. Sekarang ni mesti hujan balik. Hujan. Kadang-kadang mesin semua. Kepala kita pun rambut dah kurang. Kena pula hujan. Lagilah senang. Okay, now we go back to the 12.2. Example that we would like to do is, let's look at number 45. You are given the marginal revenue. And of course, to get the revenue is the integral of the marginal revenue, the X. And that is equal to, you have the function there, negative 30, 2x plus 1 to the power of 2 plus 30. Everything the X. So here, I missed the bracket. You have to indicate the bracket because the revenue or the marginal revenue is the whole function here. So let me make it clearer. So that's the thing that I want to equal to. Okay, budget revenue is the whole thing. So you need to put a bracket for the two terms and then you put the integral sign. Okay, now if, like I said, I did earlier, I missed that bracket. I only put like this, or I didn't write this bracket. I just put the X over here. Okay, this is wrong. All right, this is wrong. This doesn't mean anything. This one, nothing, no meaning. What is the meaning? Nothing. Because the integral is for the first term, the X is for the second term. So what is it? Doesn't mean anything. So now we are looking at the integral of the whole terms. So you have to put, I think you better put bracket macam ni. Put the bracket that indicate we are going to integrate all the terms. And all the terms are what? Are marginal. Okay, so make sure when you have more than one term like this, you put a bigger bracket to indicate that you are integrating the whole thing. Unless, okay, unless we are integrating only one of the terms. Okay, then that's another story. So what you do here is you have to break out the terms. You have to integrate the first, integrate the second. Now, the second one is very simple. The second term is, of course, very simple. This one, we can do it right away. This term here, okay, need some work. So what you do another integral just for that first term. So you integrate the thing here, negative 30 over 2x plus 1 squared dx. This is just to get the integral for that part. So you do it separately in order for us not to commit error. Okay? All right. Now, I want you to do this. Okay, I give you 3 minutes. Do that thing. Apply the power rule. Okay, as we do, you discuss. First thing, what do we need to do? In order for you to find the integral, what is the first thing that you need to do for the terms? To any of the terms? Okay, anybody? Apa kita kena buat dulu? Baik, cuti raya ni semua dah lupa ke? Okay, apa kena buat dulu? Ni je, benda ni je. For that part, if you want to find the integral, what is the first thing that we need to do? Okay, buat dulu. Okay, what is the first thing that you need to do? Anybody?
Sir,
Yes.
is it to take out the negative 30?
You can take out the negative 30, all right? But that is secondary. What is the most important thing that you need to do? You have to handle the terms in the denominator, 2x plus 1 to the power of 2. What do you do to that term?
We move it up.
You have to move it up, okay? So that becomes 2x plus 1 to the power of negative 2. All right? Then only you let u be the terms in the bracket. And then at the same time, you can bring the negative 30 out. All right? Okay, good. Okay, go ahead, do it. So you have this. You have negative 30. Okay, we take it out. And then the terms in the bracket will be 2x plus 1 to the power of negative 2 dx. Okay, then only we can apply the power rule. Okay, what do you get? What is the integral? Now, if I let u be equal to 2x plus 1, then what is u prime? If u is equal to 2x plus 1, then u prime is equal to 2. All right, now do we have a 2 in the function there? You don't have a 2. Okay, you are given what? You're given 1, which is not equal to u prime. So what do we do in order for us to get that 2? Okay, what do? You multiply by what? So multiply by anybody.
$15, sir.
Multiply by 15. Alamak. Okay, multiply by 15, you cannot, because what you want is you want a 2. Okay.
Oh, betul.
Multiply by 4/2. Okay, 15.
Oh, betul.
You multiply by 2/2 lah, because you want a 2. All right, you cannot multiply by 4/2. Okay, because you don't want a 4. And then furthermore, I cannot multiply by 4/2 because 4/2 is equal to 2. Okay, you can only multiply by what? By ratio of numbers equal to 1. Ratio of the same number equal to 1. So here you need a 2. You multiply by 2/2. You cannot multiply by 15. Why you want to multiply by 15? Because what you need is 2. Okay, so if you multiply by 15, I don't know what is the reason. All right. Okay, but having said that, but if you talking about 15, I can break out that 30. So that 30 is equal to what? It's equal to negative 15 multiplied by 2. So if what you mean is I will break out the 30, okay? So you put the 15 the outside, the 2 you bring into the integral, then that is correct. Okay, you can also do that, but I don't want to confuse ourselves. Sometimes, if you put in 2 things, might be confusing. So we will maintain with our basic concept. You multiply by the number, the ratio equal to 1, which is the one that you need in order for you to get the u prime. So you multiply by 2, you keep the denominator 2 on the top, and then the numerator, you keep the numerator on the top, okay, put into the integral, and then the denominator you bring out. So essentially what you get will be something like that. Okay, so you do that. Then what do you get? You bring the denominator out. So what do we get? Okay, now find the integral. Okay, so you multiply by 2/2. So what we'll get is negative 30. Okay, you bring the denominator out. You must divide by 30. No, divided 30 with it, and then you got the 2x plus 1 of negative 2. And then you bring the numerator here, okay, to the integral dx. So now you will get, this is u prime This is u. So I get negative 15. Okay. The integral of u to the power of negative 2 u prime dx. So the integral will be equal to negative 15 u to the power of 3. I'm sorry, not 3. Negative 2 plus 1. Berapa? Negative 2 plus 1 is
Minus 1.
negative 1. Negative 1. Negative 2 plus 1. Divided by negative 1 plus c. Okay, the constant. And you put back the u, that will be equal to negative 15 2x plus 1 to the power of negative 1. Okay, negative 15 over negative 1, that becomes positive 15 plus c. Betul tak?
Alright, sir.
Right. So that would be our answer. That will be our revenue for the first part. Okay, for first part, and of course the second part it will be 30x. So therefore, our revenue will be equal to 15. Now you can bring the 2x plus 1 down. 2x plus 1. Okay. La ilaha illallah. Plus 30x. Okay, that is the second term, and then plus the constant c. Okay, so that is our solution for the question number 40. So here, okay, one is you want to do the power rule. Secondly, if we have many terms, okay, more than one term, and you require, the extra work to find the integral of one of the two terms, or a few terms in the whole thing. So what you do, you take it out, okay? Take it out, find the integral, because it's not that easy to get the integral right away, okay, from here. It's not like 30x would be senang, But if you have something like that, where you have to apply the general power rule, it's good that you take it out, do the integral, and then put back into the original function. Okay. So what you get will be the revenue. All right. So we are done with 12.2. I give you already some questions. And then now we move on to the last part, 12.4. 12.4 is application proper. But, what you have is in 12.4 is additional applications. That will be the cost, profit, and, one of the macroeconomic application. So let's look at the first example in 12.4. We look at the total cost. So now we go to 12.4, example 1. Here we are looking at cost. All right. So cost. What are you given? I want you to read that example here. What are we given? You are given the marginal cost function. Okay. And the X is the product in units. Cost is in dollars. Now, if the fixed cost is equal to $10,000, find the total cost. So the example number 1, you want to find the total cost function, find C. All right. And also you are given the fixed cost. Okay, given fixed cost, FC equal to what? Equal to $10,000. So that is our objective. So what you do now is that you integrate the marginal cost. So cost is equal to what? Integral of the marginal cost dx. Just like marginal revenue. So integrate marginal cost, you get the cost. And that is equal to the integral of the thing that we are given, very straightforward function, 3x plus 50 dx. So what do I get? You got 3x squared over 2 plus 50x plus c. Now we cannot use c now because this cost. C is already cost, so we use k. Right? Where k is what is constant. So now you want to find the value of k. What is it? So we are given, okay, you're given here. Fixed cost is equal to 10,000. Now, what is fixed cost in terms of x and c? You know fixed cost is 10,000. What is it actually in terms of x and c?
If x 0, c equal to 10,000.
So if x is equal to 0, the total cost is 10,000. So that is our concept of fixed cost. The cost of producing 0 output. All right. So that is fixed cost. All right. Fixed cost is when x equal to 0, c is equal to 10,000. So now you substitute here into c. Okay. Now what you get will be 10,000 equal to 3 over 2, 0 plus 50, 0 plus k. So therefore, k is equal to 10,000. So now you have the cost function. And what you do, substitute that k into the c, okay, into the c cost function. You will get what? You will get 3 over 2 x squared plus 50x plus 10,000. So that is our cost function. Okay, now let's look at example number 2. Okay, example number 2. You are given also here the fixed cost, all right? But the cost function is given where you require to do the power rule, the general power rule. But it's similar to the one that we were doing for the revenue. You have 2x. Look at example number 2. I think we do this again. So example 2. So you are given the marginal cost, and then you have the fixed cost equal to 11,125. So that is the fixed cost given. And then you want to find the cost of producing 300 units of the good. So you have a few things that you need to find, okay? Number 1, you need to find the K, all right? And of course, after that, you get the cost function. And then number 2, you need to find the cost at X equal to 300. So basically, these are the 2 things that you need to find. Nothing difficult. You are given the marginal cost. So the cost is equal to the integral of 3 2x plus 25 to the power of a half dx. Okay. So here, everything is given in the book lah. Okay. But I don't want you to look at the book. I want you to do it by yourself. Get for me the integral of this function here. Okay, do it now. I'll give you 2 minutes. Okay, what do you multiply the thing with? in order for you to get the u prime. Or before that, what is u prime?
2.
The
2.
prime is 2. Okay, your u prime is 2. So what do you multiply the function with in order for you to get the 2? You multiply by what?
2/2.
You multiply by 2/2. All right, so you let u be equal to 2x plus 25. Don't worry about the 3. So you got u prime is equal to 2. All right, so I need u prime equal to 2. So what do I do? Multiply by 2/2. So if you do that, then our integral will be equal to, you got the 3 there, okay, bring it out. And then you bring also the denominator out. So now you got 2x plus 25 to the power of a half multiplied by 2 dx. So the integral will be equal to 3/2, 2x plus 25. Now I put in right away, the thing, because now we know that u is equal to the thing, and then you increase the power by 1, so that it becomes 3/2 divided by 3/2. Plus, habis dah, tak ada plus, itu je. Okay, plus k, constant. Okay, so that will be it. Now 3/3, 3/2, 3/2 will cancel out. So you got 2x plus 25 to the power of 3/2 plus k. Okay, all right. Now you need to find the value of k. So you are given, all right, you are given the fixed cost. So you are given the fixed cost, that means x equal to 0. The cost is equal to 11,125. So what do we do? That thing you need to substitute. All right. So let's do the substitution. You are given, okay, when x equal to 0, cost is equal to 11,125. Okay, now another common mistake that we may do here is we can always, all right, we tend to assume that the value of the k will be equal to the fixed cost. Okay, this may not be true. Okay, some cases it can be true, some cases it may not be true. It depends on the function. So this thing here, that will depend on the function. So if you look at this example, the k is not equal to 11,125. All right. If you look at the first example, the k is equal to the fixed cost, which is 10,000. So you look here, the value of the constant k may not be necessarily equal to the fixed cost. All right, because that will depend on the nature of the function. So we have to do the substitution. Whatever it is, you do the substitution, and then you determine k. So we do that. So what do I get? I get 11,125 equal to, put in the 2, 0, all right, 2, 0 there, 2, 0. Mana function ini? 2x plus 25. Okay, 2, 0 squared plus 25 to the power of 3/2 plus k. And here, everything in the bracket is not 0. Okay, you have 25 to the power of 3/2 plus k. Okay, now you need to find 25 to the power of 3/2 berapa? Cepat-cepat, siapa ada calculator? 25, 5 to the power of 3, 75 lah. 5 to the power of 3, 75. So 75. So 11,125 minus 75. Okay, dengar kita dengar? Dengar saya? Sebab tadi saya punya tiba-tiba dia disconnected. So you have K. This thing here is 1 to 5. 1 to 5. So therefore K is equal to 11,000. So K is equal to 11,000. So the cost, all right, the cost now becomes what? 2x plus 25, everything to the power of 3/2 plus 11,000. So here you see that the value of the K, which is the constant, is not equal to the fixed cost. All right, so don't assume that Hi. Tadi. Oh. Okay. Can you hear me? Ah.
Yes.
Yes,
Screen
sir.
nampak ya? Screen nampak ya? Ah, okay. All right. Okay, good. So that is the cost function. Now you want to find what is the cost of producing 300. So now it's just simple substitution. Where at x equal to 300, you find the cost. Or you can find another point, x equal to say 69, then you can find the cost. Okay, so you can do that. So that is example 1 and 2, which is cost. So we are look at revenue. We look at cost. So now let's move on. We look at the profit. So for profit, here, okay, here what you do here is what you are given. Okay, you are given the marginal revenue, you are given the marginal cost. And then the total cost of producing 10 units is 700. And then you want to find what is the profit function. And then what is the output level that maximize the profit. Okay, so what you do here is this. You need to find, okay, you need to find the cost function, because we know profit is equal to what? Revenue minus cost. Yeah, the profit is cost. So you are given, okay, you are given the marginal revenue. That will give you revenue function. And you are given the marginal cost, we can find cost function. So after you got the revenue, you got the cost, then we get the profit function. So basically that is what that example is about. Okay. Now, once you have the profit function, how do you get the maximum profit? We do the derivative. Okay, you do the derivative. The derivative, and then you use the second derivative test to check for whether you get the maximum or not. Okay. All right. So just look at the marginal revenue and the marginal cost. So if I want to find the revenue, that means I have to integrate the marginal revenue. And if you look at the book, they have the function, you know that the constant K is equal to 0. So therefore our revenue is equal to, okay, look at the steps, will be equal to 200 x minus 2x. So that's for revenue. Now for the cost, integrate the marginal cost dx, and that will be equal to what? That will be equal to 50x. You got the 50x plus x squared plus k equal to the cost 50x plus x squared. You know, you do the integration, you have 50x plus x squared plus k. Now, in this example, we are not given the fixed cost. Okay, you are not given a fixed cost, but you are given an initial condition. You are given a point. So you are given a point, and that point is what? When x equal to some value, you are given the cost. So at x equal to 10 units, if I produce 10 units of the product, the cost is equal to how much? 700. So from here, I can find K. So substitute into the C, all right? What do we get? We get 700 equal to 50, 10 minus plus 10 squared plus K. So I got here 500, 500 plus 100, 600. 600 you bring there, become negative. So K is equal to 100. Betul tak? Tengok balik. 100 Betul 100 Alright. So K is equal to 100. You put in the thing again. So your function now becomes 50x plus x squared plus 100. So that is our cost. Put both into the profit. Okay. So therefore, our profit will be equal to R minus C. R will be equal to here, this thing here. The cost will be equal to sekarang ni 100 lah. Okay. So put back into the profit, then you get the profit function. Okay. All right. So what is the profit? Put in everything. Because the book, the book already simplified. So we don't simplify it yet. Okay. You put the revenue, you put the cost, and see what is the profit after you simplify. So let's do that. So the profit is equal to the revenue minus cost. What is revenue? Revenue is 200x minus 2x squared minus the cost, which is 50x plus x squared plus 100. Sudah. Okay, lepas itu barulah simplify. Then what do we have? We have 150x. All right, 200 minus 50, and then negative 3x squared minus 100. So that is our profit function. So in order for you to do everything the maximum profit, then we do the normal method using the derivative. Okay.
Sir,
Yeah.
I still confused why the K for the revenue is 0.
Okay, the K for revenue is 0. All right. Let's say, okay, this one. Okay, you got, let me go back to the revenue. You got the revenue equal to 200x. Okay, revenue is equal to 200x minus 2x squared plus the value constant. Okay, suppose call it K. All right, K is constant. Now for revenue, if I don't sell anything, X is equal to 0. What is your revenue?
0, sir.
0. Revenue is equal to 0. Okay, so therefore, in other words, what we're saying is R at 0 is equal to 0. So you put this is the point, that is the point. That is the initial condition. Okay,
Alright,
initial condition, that is the point. Okay, now you got it?
I got it. Thank you, sir.
But that is only true for revenue. Okay, it's not true for any other function. It's not true for cost. It's not true for any other function. It's only true for revenue. Okay, so that is why for revenue, they don't give you any information. Okay, they will not give you any information. They just will tell you find the revenue, and then find revenue at X equal to something. It is understood. Okay, we should understand that already. It's a given thing that for revenue, X equal to 0, R is 0. Okay, all right. So the thing is, for revenue function, they will not give you, they will not say, when X equal to 0, revenue is 0 or whatever, they will just give you, or they will just ask you to find the revenue function, all right? And then they will ask you to find what is the revenue at given some point, because they assume, okay, that we know it's a fact that when X equal to 0, R is 0. Okay, paham? All right. Okay, good. Thank you. Okay, so that is profit, example number 3. And then the last example that I want to look at is the national consumption. So national consumption is on the last example, example number 5. This is more on the macroeconomic. So if you recall the principles of macro, you will, this thing will be familiar. You have the marginal propensity to consume, you have the consumption function, everything like that. But the idea here is this. We are looking at the economy as a whole. Okay, let's say the Malaysian economy or the Indonesian economy. So it's the whole economy as a whole, not household. Okay, you are looking at the economy as a whole. So the consumption, C here, is the national consumption. National consumption level of all the household. And then you got Y, we call it the income, national income. Okay, everything national income. And then S, national savings. Now, your income, all right, our income is equal to what? The national income that everybody earn is either being used for what? For consumption. If you have any extra, you save. So this is the only two uses of income. Either you consume or you save, or both. Okay? Sometimes people consume all their income, no saving. Sometimes people don't save all their income, Sometimes people consume some proportion, save some proportion. So national income is equal to C plus S. Now you can write that in terms of C is equal to Y plus minus S. Now if I take derivative of the C with respect to Y, okay, you differentiate. C and S, okay, with respect to Y. What do I get? I get dC dy equal to dy dy minus ds dy. Okay, if I differentiate the variable, if we differentiate one variable with respect to the same variable, let's say dx or dy dy, what is it equal to? It's just equal to 1. Okay, just equal to 1. So therefore, here, dc dy is equal to 1 minus ds dy. So you can just readjust the term. You can say that dc plus dc dy plus ds dy is equal to 1, or you can say that ds dy is equal to 1 minus dc dy, or you can say that dc dy is equal to 1 minus ds dy. So from here, at least you can readjust into two other things. Okay, all right. So this is the derivative of the C and S with respect to Y. Now, what do you call those? We'll call this C dy. That is the change of the consumption with respect to the change in income. All right. So dC dy is called the marginal propensity to consume. Okay, because that is the term they use. So if you look at the book, they call it marginal propensity to consume. They refer to that page. So you look at page 768. And ds dy, that is the change in the saving with respect to a change in income. That is the MPS, marginal propensity to consume. Oh no, I'm sorry, to save. Now, suppose the CDY, all right, equal to the MPC, let's say equal to 0.7. What does it mean? So you think about it as the interpretation that we have been doing all the way. So you think of it as delta C over delta Y. So everything is in dollars. So if the dC dy is equal to 0.7, what does it mean? It means that if national income, okay, or just say income, if national income increases by $1, then what happened to consumption? This is just interpretation of the slope, all right? If income increased by $1, then consumption, what happened to consumption?
Will also increases by 0.7.
Consumption will increase by 70 cents. Okay, or $0.7. All right. So income increased by $1, I consume 70 cents. Or my consumption will increase by 70 cents. Okay, so in other words, your MPS will be equal to what? MPS will be equal to 0.3. All right. MPS plus MPC is equal to 1. Or MPC is equal to 1 minus MPS. So that's how you interpret. Interpret is just like the slope. MPC is the slope of the consumption function. All right. Okay. So if you look at the example 5, you are given the MPC, then the consumption function is the integral of the MPC, dC dy, dy. All right. So if you look at that example, that will be equal to the integral of 0.3 plus 0.4. Now you have a square root of 5. So bring it up, that becomes y to the power of -1/2 dy. And I don't think that's very difficult to integrate. So you got 0.2x. Kita guna x selalu tu ingat x. Benda tu y. Alamak, saya punya internet dah tak ada . Ada lagi. Saya dah putus. Okay, 0.3y. Sebab dah penting. 0.3y plus 0.4y. Negative half plus 1, there will be positive half divided by 1/2. Okay, plus the constant k. So that is our consumption function. And now you are given that when the consumption is equal to, when income is 0, no income. Even though you have no income, you still have to consume, otherwise you're going to die. All right. So y equal to 0, C is equal to 6 trillion in national. Okay, we are not talking about individual. Okay, no income, you still have to consume. All right, otherwise everybody will die. So you got this thing here. Now you substitute into the C. All right, substitute into the C. So you got 6 equal to 0.30 plus 0.4 divided by half. So 0.4 multiplied by 2, that means you got 0.8. 0.8. 0.8, 0 to the power of half plus k. So therefore, k is equal to 6. K equal to 6. equal to 6, then you have the consumption function. Okay, so if you look at that example, you put the k into this thing here, then you got the consumption function, and then yeah, we only needed to get the consumption function, and then example number 6, you get the MPS. So that's it. Yeah. Then you look at example number 6. Example number 6 is what? Okay, I'll give you time. We take 2 minutes. Okay, 2 minutes. You look at example number 6. All right, are you done here? This one? All right, so k equal to 6, and then you rewrite the consumption function. Now, for example, number 6, you are given the MPS. Okay, so example 6, you're given the MPS. MPS is equal to 0.25. But they don't want you to find the saving function. They want you to find C. Okay, consumption function. And then you're given when income is equal to 0, consumption is 9. So when Y is equal to 0, C is equal to 9. So you have to find that C. So how do you do that? Now you do this by using the fact that MPC is equal to what? MPC is equal to 1 minus MPS. Right? That is equal to 1 minus 0.25. That is 0.75. So that is our MPC. Now, given the MPC 0.75, you can find the consumption function. So I want you to look at example number 6. Just finish it up. So for 12.4, okay, I want you to do question number 1, number 2, number 6, and then number 12. And then for the national consumption, number 18, 19. Okay, so that will do it for chapter number 12. Chapter number 12, the end. So we are done with chapter number 12. The other parts we don't have to do. Next week, we are going to start with definite integral. That is, an extension of what we are discussing now. And we have 3 more weeks. Okay, we have 3 weeks left, not much time. Okay, next week we have 3 more weeks. Actually, after the break, we have only about 3 weeks and a half. We don't have a class on the Monday. So you have 3 more weeks. And then you have 2 more topics to cover. So don't worry, okay? We just cover as much as we can. I don't want to go fast, all right? I have to go, the speed that we're going now, because if I go faster, maybe some people might not be able to follow. We go at the regular speed, then we'll see, how much we can cover. All right, but I think at least we can cover a little bit of matrices. So don't worry too much. I will only ask you in the final exam the things that we discussed in class. All right, don't worry about other sections, because now the final is only up to the individual lecturer. So your final will not be equal to the final of the other section. Okay, your final is only up to the sections in my classes. Okay, all right. So don't worry about other people. We'll worry only about ourselves. Okay, all right. Anything else? Any other question?
No, sir, inshallah.
Okay, good. Hey, in Indonesia, during Hari Raya, what is your main food? Tempe. Apa nama benda tu?
Opor ayam dan rendang, sir.
Hah?
Rendang,
Opor
sir.
dan rendang.
Rendang ayam.
Rendang sapi, sir.
Rendang sapi,
Kau.
Oh, sama dengan kita lah. Kita pun buat rendang. Tapi maybe the rendang is different lah. Oh, that's nice to see.
For our for cooking rendang.
How is your rendang, for us, for me in my place, we eat rendang with lemang. You have lemang in Jawa?
We don't have lemang in Jawa, sir. We have nasi uduk.
In Sumatra, I think in Sumatra have lemang because
Yeah.
we are more similar to Sumatra. Many of us, here actually our ancestors coming from Sumatra.
Oh, really, sir?
Yeah, really. Many years ago, people from Sumatra they immigrate to the peninsula. Many of them from Pagaroyong, from Aceh, all this. So apa nama benda lemang tu apa nama? What do you call it? Lemang, that lemang? Nasi
uduk, sir.
Nasi uduk. Yeah, I heard nasi uduk. Nasi uduk. That's interesting. But due to the MCO, we didn't do lemang. We just buy. But to make more fun, we should be able to cook lemang on our own. That will be much better. But during this time, we buy everything.
How long do we need to cook the lemang, sir?
If you cook slow, all right, because you need to, if you put a very strong fire, the benda tu hangus, benda lama dia
Gosong, sir.
become crash, become like kerap. So you have to cook slowly. So sometimes, it may take 5 hours. 5 hours.
5 hours?
5 hours, because you need to use the slow fire, and that fire must come from wood. The taste will be better lah. Okay,
yeah.
you use rubber wood, the wood, the forest wood, that will have a natural flavor. Normally 5 hours. If I do it, normally 5 hours. So that is lemang.
It's similar like rendang, sir.
Rendang, we cook rendang not so long, I normally cook rendang will take me about 2 hours, 3 hours, depending on whether it is beef or chicken. Chicken will cook faster because chicken soft, but beef will take longer. So maybe beef will take about 3 hours. Chicken, 2 hours, will be cooked.
We take 4 until 5 hours.
Yeah, masak rendang.
For rendang.
What do you put in? That cook that long. I don't think you know how to cook
A
it.
lot of.
Your parents.
Yeah.
Yeah. Okay. Right. Okay. Nice to share with you. Something that we don't actually know. Even though we are neighbors, but sometimes we don't know. Okay. All right. Anything else?
Sir, why?
Yeah.
When is our not holiday? What we call it? Is it Monday? We have a class.
Oh, is it holiday Monday?
I don't know, sir. You just said.
No, I don't think Monday is holiday.
Wednesday.
Holiday. Wednesday holiday.
Wednesday, sir.
Holiday apa pula?
I think it's Wesak on Wednesday.
If it is Wednesday holiday, then we miss another day. All right. So we miss another day. That means 3 weeks. We have 6 classes. Minus 1, that becomes 5 more classes that you have left. And I owe you 1 more class. The class that I canceled last time. So instead of having 7 classes, we have only 6 more. So that makeup class we have to make. Maybe we meet on Saturday. Ataupun on the Wesak day, if there is nothing to do, we don't celebrate Wesak. Maybe we have the class on Wednesday. Tak apa lah. Lagipun everybody stay home, Raya pun dah tak ada lah kan. Takkan nak jalan raya, mana boleh. SOP. So probably on the Wednesday, we'll continue, we have a class. That class will be the makeup class. So we don't have to have another class during the weekend. Okay lah. Wednesday, it's nothing for us actually. All right. Okay, thank you for informing that. I didn't know that Wednesday is a holiday. So keep that in mind. If you have, if we have less choice, what we'll do, we have the class on the Wednesday. That will cover the class that I canceled last time. Okay. All right. So with that, I will see you again next week. You can do the questions. Have a nice weekend. Beraya lagi pun tak apa. Beli lagi, makan lagi lemang. Saya pun makan lemang banyak dah ni, sakit perut dah. Alright, I'll see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Thank you,
Waalaikumsalam,
sir.
sir. Thank you, sir.
Thank you, sir. Get well.
Alright. Have a nice
Thank you,
day.
sir.
Menikmati kuih raya, sir.
Kuih raya? Mana ada kuih raya? Raya ni tak ada kuih. Makan lemang je dengan dodol. Dodol pun pergi beli dekat Kuala Lumpur. Order dekat Kuala Lumpur. Susah nak cari lemang. Saya suka lemang sebab saya orang Pahang. Lemang Pahang sedap. So susah nak cari. Orang lain buat tak sedap. Kena cari dekat Pahang. So semalam saya jumpa dekat Shopee. Orang Kuala Lumpur ada jual. Try lah tengok macam mana.
Thank you, sir.
Okay, thank you.